Hello and welcome guys to the second part of circles where we are going to discuss theorems and solve sums based on cyclic properties of circles. We have already covered the angle properties of circles in part 1. If you haven't watched that video, go watch it. The link to that video will be in your top right corner as well as in the discussion box below. Watch this video till the end, and if you like it, do hit the thumbs up button, share this video with your friends and subscribe to EduCeption if you haven't. Also, press the bell icon to get notified of all our videos. Without further ado, let's begin. Before beginning with the theorems, let me tell you what a cyclic quadrilateral is. A quadrilateral inscribed in a circle is a cyclic quadrilateral. What is that? Say we have a circle and a quadrilateral is inscribed in it. Say A, B, C and D. So this A, B, C, D is a cyclic quadrilateral. We can also say that the vertices of a cyclic quadrilateral lie on the circumference of the circle. C at A over here, at B over here, at C over here and at D over here. So this is basically a cyclic quadrilateral. It's very simple. Now let's begin with the first theorem. What does it say? It says the sum of opposite angles of a cyclic quadrilateral is 180 degree, or the opposite angles of a cyclic quadrilateral are supplementary. Say we have a circle over here and a cyclic quadrilateral A, B, C, D. We can see that angle A and angle C are opposite to each other and angle B and angle D are opposite to each other. So this theorem basically says that the opposite angles of a cyclic quadrilateral are supplementary. That means angle A plus angle C will be 180 degree and angle B plus angle D will be 180 degree. As simple as that. Let me write it down. So we get angle DAB plus angle DCB is equal to 180 degree and angle ABC plus angle ADC is equal to 180 degree. Say this angle over here is x degree, that means angle ABC is x degree, and this angle over here is y degree, that means angle ADC is y degree. Then we will have x degree plus y degree is equal to 180 degree. So this is what this theorem is trying to say. It is very simple yet very important. So understand this theorem properly. Now we will move on to the next theorem. Moving on to the second theorem. An exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. What does this mean? Say we have a circle and a cyclic quadrilateral A, B, C, D. One of the sides of the cyclic quadrilateral AB is extended to E. So we get an exterior angle over here. So angle CBE is an exterior angle. And the theorem says an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. That means angle CBE, that is this angle, will be equal to the opposite interior angle, that means this angle. So we get angle CBE is equal to angle CDA, as simple as that. Now say that I extend the side DC to M. So I get this exterior angle. So I get angle BCM as an exterior angle. This exterior angle will be equal to the opposite interior angle. So basically angle BCM will be equal to angle BAD. So angle BCM will be equal to angle BAD. Okay. Now that we are done with both the theorems, we will move on to the sums. Let's begin with sum number 1. In the adjoining figure, O is the center of the circle. If angle AOC is equal to 150 degree, you have to find number 1 angle ABC and number 2 angle ADC. This is the given figure. Angle AOC is given 150 degrees. In the first one, we have to find angle ABC. So angle ABC. So this angle. In the previous video, the first theorem that we studied was the angle subtended by an arc at the center is double the angle subtended by it at the circumference. So using that we can find angle ABC. We can see that AC is an arc of the circle. It subtends an angle at the center O and it subtends an angle at the circumference at B. So this angle will be double this angle. So using this we can find angle ABC. So let's do that. So number 1, angle AOC will be double angle ABC, and beside this I will write the theorem that I used, that the angle subtended by an arc at the center is double the angle subtended by it at the circumference. So I get angle ABC is equal to half angle AOC. So I get angle ABC is equal to half into 150 degree. So I get angle ABC is equal to 75 degree. So I get angle ABC as 75 degree. Now the first theorem of today's video was the opposite angles of a cyclic quadrilateral are supplementary. That means the sum of opposite angles of a cyclic quadrilateral is 180 degree. So we have angle B and angle D. They are both opposite angles of a cyclic quadrilateral. The cyclic quadrilateral is A, B, C, D. So the sum of angle B and angle D will be 180 degree. So we get angle ABC plus angle ADC is equal to 180 degree, and using that we can find angle ADC. So let's do that. Number 2, angle ABC plus angle ADC is equal to 180 degree, and beside this I will write the theorem that I used, that the opposite angles of a cyclic quadrilateral are supplementary. So I get angle ADC is equal to 180 degree minus angle ABC. So I get angle ADC is equal to 180 degree minus 75 degree. So I get angle ADC is equal to 105 degrees. Simple. Now we move on to the next question. Moving on to question number 2. In the given figure, AB is the diameter of the circle with center O. If angle BCD is equal to 130 degree, you have to find number 1 angle DAB and number 2 angle DBA. This is the given figure. AB is the diameter of the circle and angle BCD is given 130 degree. In the first one we have to find angle DAB, which is angle DAB, that means this angle. Now the first theorem that we studied in this video was the opposite angles of a cyclic quadrilateral are supplementary. We can see that ABCD is a cyclic quadrilateral. So for this cyclic quadrilateral, the opposite angles will be supplementary. We can see that angle A and angle C are opposite angles of this cyclic quadrilateral, so they will be supplementary. That means the sum of the angles will be 180 degree. So we will have angle DAB plus angle BCD is equal to 180 degree, and using that we can easily find angle DAB. So let's do that. So number 1, angle DAB plus angle BCD will be equal to 180 degree, and beside this I will write that the opposite angles of a cyclic quadrilateral are supplementary. So I get angle DAB plus 130 degree is equal to 180 degree. So angle DAB is equal to 180 degree minus 130 degree. So angle DAB is equal to 50 degree. So we get our first answer that angle DAB is equal to 50 degree. So this is 50 degree. In the second one we have to find angle DBA, which is angle DBA, that means this angle. Okay. Now we know that AB is a diameter of this circle. So AB divides this circle into two hemispheres, one this and one this. In the previous video, we studied a theorem that angles in a semicircle are right angle. So we can see over here that angle ADB is an angle in a semicircle. So it will be 90 degree. So we get angle ADB as 90 degree. I'll write it down. Angle ADB is equal to 90 degree. And beside it I'll write that angle in a semicircle is right angle. Now we know this angle, we know this angle, so we can easily calculate angle DBA over here. How? We know for a triangle the sum of its angles is 180 degree. Using that we can find angle DBA. So in triangle ADB, the sum of all three angles will be 180 degree. So we have angle ADB plus angle DAB plus angle DBA is equal to 180 degree. And beside it I'll write that the sum of angles in a triangle is 180 degree. So I get angle ADB, that's 90 degree, plus angle DAB, that's 50 degree, plus angle DBA, we have to calculate that, is equal to 180 degree. So we get angle DBA is equal to 180 degree minus 90 degree minus 50 degree. So we get angle DBA as 180 degree minus 140 degree, that's 40 degree. So the second answer, angle DBA, is 40 degree. This is 40 degree. Okay. Now we move on to the next sum. Let's begin with sum number 3. In the adjoining figure, if angle DBC is equal to 58 degree and BD is the diameter of the circle, you have to calculate number 1 angle BDC, number 2 angle BEC, and number 3 angle BAC. This is the given figure. BD is the diameter of the circle and angle DBC is given 58 degree. So let's begin. First of all, we have to calculate angle BDC. What's that? That is angle BDC. That means this angle over here. Now we know that BD is the diameter of the circle. That means it is dividing the circle into two semicircles, one over here and one over here. And we know the angles in a semicircle are right angle. We can see that angle BCD is an angle in a semicircle, so it will be 90 degree. So this angle over here, that is angle BCD, is 90 degree. I'll write it down. That angle BCD is equal to 90 degree. And beside it I'll write the theorem that I used, that is angle in a semicircle is right angle. Okay. Now check out triangle BDC. In triangle BDC we know two angles, 58 degree over here and 90 degree over here. So we can easily calculate the third angle. As we know, the sum of all three angles of a triangle is 180 degree. So let's do that. So in triangle BDC, angle BDC plus angle BCD plus angle DBC is equal to 180 degree. And beside it I'll write the sum of all three angles of a triangle is 180 degree. So we get angle BDC plus 90 degree plus 58 degree is equal to 180 degree. So angle BDC is equal to 180 degree minus 90 degree minus 58 degree. So we get angle BDC is equal to 32 degree. So we get our first answer, that angle BDC is 32 degree. So this angle is 32 degree. In the second one we have to calculate angle BEC. What's that? That is angle BEC, the angle over here. Now we can see that BECD is a cyclic quadrilateral and angle E and angle D are opposite angles of a cyclic quadrilateral, and we know that opposite angles of a cyclic quadrilateral are supplementary. So using this we can easily find this angle over here, that is angle BEC. Number 2, angle BEC plus angle BDC is equal to 180 degree. Therefore angle BEC is equal to 180 degree minus angle BDC. So angle BEC is equal to 180 degree minus 32 degree. So we get angle BEC is equal to 148 degree. So we get our second answer, that angle BEC is 148 degree. This is 148 degree. And over here beside this I will write the theorem that I used, that opposite angles of a cyclic quadrilateral are supplementary. In number 3 we have to calculate angle BAC. What's that? Angle BAC, that means this angle over here. Now we can see that BC is an arc of the circle and BC is subtending two angles at the circumference, one at A and one at D. And we know the angles in the same segment are equal. So we will have angle BAC will be equal to angle BDC. So if this is 32 degree, this will also be 32 degree. So we get our third one, angle BAC is equal to angle BDC. Therefore angle BAC is equal to 32 degree, our third answer. And beside this I will write angles in the same segment are equal. Now that we are done with this sum, we'll move on to the next sum. Moving on to sum number 4. In the adjoining figure, angle BCE is equal to 80 degree and angle BAC is equal to 25 degree. We have to find number 1 angle CAD and number 2 angle CBD. This is the given figure. Angle BCE is given 80 degree and angle BAC is given 25 degree. So let's begin. First of all we have to calculate angle CAD. What's that? Angle CAD. So this angle over here. Now we can see that ABCD is a cyclic quadrilateral and one side of the cyclic quadrilateral DC is extended to E. So we get an exterior angle, angle BCE is equal to 80 degree. So I'll write it down. Exterior angle BCE is equal to 80 degree. Now the second theorem that we studied in this video was the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So this angle over here, that is 80 degree, will be equal to the opposite interior angle, that means angle DAB. So the whole thing over here will be 80 degree. So I'll write it down that angle DAB will be equal to angle BCE. So angle DAB is equal to 80 degree. And beside it I'll write the theorem that I used, that is an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Now we have to calculate angle CAD, that is angle CAD, that means this angle. Now we know the whole thing is 80 degree and this over here is 25 degree. So angle CAD will be 80 degree minus 25 degree, as simple as that. So let's calculate it. So we get angle CAD is equal to 80 degree minus 25 degree, that is angle CAD is equal to 55 degree. So we get our first answer, that angle CAD is equal to 55 degree. This is 55 degree. In the second one we have to calculate angle CBD. What is that? Angle CBD. Now we can see that DC is an arc of the circle and we know the angles in a same segment of a circle are equal. We can see the arc DC is subtending two angles on the circumference, one at A and one at B. That means we will have angle CAD will be equal to angle CBD. So if CAD, that means angle CAD is 55 degree, so angle CBD will be equal to that is 55 degree. As simple as that. So we get number 2, angle CBD is equal to angle CAD, therefore angle CBD is equal to 55 degree. And beside it I'll write the theorem that I used, which is the angles in a same segment of a circle are equal. So we get both the angles, 55 degree and 55 degree. So guys, with the end of this sum, I will end this video over here. In the next part, we will begin with the tangent properties of circles. So do watch that video. Until then, this is Rishi on behalf of EduCeption signing off.